7th of September, 1943, Leytonstone, London, England. The concept emerged from the Directorate of Miscellaneous Weapons Development in a requisitioned warehouse that still smelled of coal dust and machine oil, where Lieutenant Commander Neville Shute Norway and a small team of naval engineers studied reconnaissance photographs of the Atlantic Wall fortifications spread across a metal table under a single overhead lamp that buzzed with irregular current, casting shadows across concrete barriers 15 feet high and gun emplacements dug into Norman cliffs that would meet any amphibious assault with overlapping fields of fire from MG-42 machine guns and 88mm anti-tank weapons. The problem was one of physics and violent force: how to deliver 2,000 pounds of high explosive directly against reinforced German beach defenses without exposing landing craft to direct fire during the critical minutes when Royal Marines and Army infantry would pour onto French sand, and the solution that took shape in technical drawings and metallurgical specifications was a device so unorthodox that even within the experimental weapons branch it generated skepticism. A massive wooden drum 10 feet in diameter, mounted in parallel with an identical drum 3 feet away, the two connected by a central axle carrying the explosive payload, the entire assembly driven forward by dozens of cordite rockets attached to the outer rims of both wheels, creating a self-propelled rolling bomb that would theoretically race up the beach at 60 miles per hour, crash through obstacles, and detonate against the concrete wall with enough force to blow a breach wide enough for armor and men. The first prototype took shape in a Chatham naval workshop, where shipwrights accustomed to building MTB hulls instead constructed massive plywood discs reinforced with steel bands. The rockets, standard 3-inch cordite types used on aircraft, mounted in clusters around each wheel's circumference, 70 rockets total. Their exhaust nozzles angled to produce forward thrust through rotational force. The mathematics seemingly sound when reviewed by the Admiralty Research Laboratory at Teddington. By late November, the device had a name, taken from a nonsense poem by Samuel Foote, Panjandrum, a word meaning nothing, which suited the project's classified nature and its position outside conventional military engineering. And by December, a full-scale test article sat in a locked hangar at Westward Ho in Devon, where the sandy beach and tidal conditions resembled the Normandy coast enough to provide realistic test parameters. The weapon measured 13 feet across both drums, with the axle assembly between them, weighed nearly 1 ton without explosives, and looked like something from a fever dream or Jules Verne illustration. 2 enormous wheels connected by a shaft festooned with rockets, painted navy gray, absurd and menacing simultaneously. Lieutenant A.D. Bell, assigned as project officer, supervised the loading of the first test payload, not high explosives but ballast and sandbags approximating the weight, and arranged for a photographic team from the War Office to document the trial, understanding that if the Panjandrum succeeded, it would revolutionize beach assault tactics and potentially save thousands of lives in the coming invasion of France. But if it failed, it would be another footnote in the catalog of desperate wartime innovations that looked better on paper than in reality. The beach at Westward Ho stretched empty under gray winter sky on 7th January 1944, the wind coming off the Bristol Channel carrying salt spray and the cry of gulls, the sand hard-packed from recent rain, the tide out exposing 200 yards of flat approach that mirrored the killing grounds of Utah and Omaha beaches as described in intelligence briefings. And at 1100 hours, the first Panjandrum sat at the waterline, its rockets wired to an electrical firing system, Bell and his team positioned behind a sandbagged observation post 200 yards laterally along the beach, cameras ready, notebooks open, expecting either vindication or expensive failure, but not anticipating the chaos that was about to unfold when the firing circuit closed, and 70 cordite rockets ignited simultaneously with a sound like continuous thunder. white smoke pouring from the drums as they began to rotate, the entire assembly lurching forward across the sand, accelerating as the thrust built, 20 miles per hour, 30, the wheels throwing up spray and grit, the Panjandrum tracking straight for 50 yards before the first rockets burned out unevenly, causing asymmetric thrust, the device beginning to veer left, then overcorrecting right, several more rockets detaching completely and spiraling across the beach like enormous fireworks, one passing within 20 feet of the observation post, trailing white smoke and a screaming whistle. The main assembly now spinning wildly, careening in a broad circle, completely out of control, more rockets breaking free and shooting in random directions as Bell shouted for everyone to take cover. The Panjandrum completing one full revolution before tipping onto its side and rolling like a coin, rockets still firing in all directions until the last charges burned out and the device lay still in the surf, smoking and defeated. The sand around it scorched black. The test categorically unsuccessful, but the concept still salvageable if the rocket mounting problem could be solved, if the steering could be controlled, if the entire premise of a 2-ton rolling bomb was not fundamentally flawed from the start. 15 February 1944, Westward Ho, Devon, England. The second test incorporated modifications based on the January failure. The rocket clusters redesigned with stronger steel brackets welded directly to reinforced mounting rings around each drum circumference. The ignition system rewired, so rockets would fire in controlled sequences rather than all at once, creating sustained thrust instead of an initial violent surge. And the payload section now included a primitive guidance system, consisting of a gyroscope meant to trigger differential rocket firing to correct drift. Though Bell harbored private doubts about whether any guidance system could manage the complex physics of a rocket-propelled wheel traveling across uneven terrain at high speed. The beach was closed to civilian access, military police from the Somerset Light Infantry manning checkpoints on the coastal road, and the observation post was relocated 400 yards from the launch point after the previous trial's near miss convinced everyone that the weapon's behavior was unpredictable enough to require maximum safety margins. At 0930 hours under overcast sky that threatened rain, the modified Panjandrum sat at the low tide mark, now fitted with 88 rockets after calculations suggested more thrust would improve stability through increased rotational speed, the theory being that a faster spinning device would resist deflection better than a slower one, like a gyroscope or rifle bullet, though this ignored the reality that each rocket produced slightly different thrust due to manufacturing tolerances, and that even small variations would compound across 88 separate motors into chaotic results. The War Office photographer, Captain R.M. Woodward, set up his 35mm camera on a tripod, while a cinematographer from the Army Film Unit prepared a Bell & Howell IMO to capture the trial in motion picture. Both men positioned behind reinforced barriers after signing acknowledgement forms that they understood the risks involved in documenting experimental weapons. When the firing circuit closed at 0945 hours, the Panjandrum ignited with even greater violence than before, the combined thrust of 88 rockets producing a roar that echoed off the cliffs and sent seabirds scattering inland, the device accelerating so rapidly that it was traveling 40 miles per hour within 3 seconds, sand and smoke exploding behind it as it raced up the beach in what appeared for 20 magnificent seconds to be perfect controlled trajectory, the drums rotating in synchronized fury, the entire assembly tracking straight toward the target markers placed at the high tide line. Then sequential rocket failures began. Not from mounting bracket failure this time, but from uneven burn rates. 4 rockets on the left drum exhausting their fuel, while their counterparts on the right still fired at full thrust, creating immediate angular momentum that pulled the Panjandrum into a hard turn. More rockets detaching as vibration increased, one spinning directly toward the observation post, where Bell barely had time to shout a warning before the 3-inch rocket streaked past at head height and impacted the cliff face behind them, exploding in a burst of white smoke and rock fragments, while the main device completed its turn and began racing parallel to the waterline, now heading directly down the beach toward where a small group of sappers from the Royal Engineers were positioned near their equipment truck, the men scrambling for cover as the runaway weapon bore down on them, trailing smoke and flame and chaos. Rockets still firing in diminishing numbers, the Panjandrum missing the truck by less than 30 feet before one drum caught on a piece of driftwood, and the entire assembly flipped end over end, shedding rockets and structural components, finally coming to rest upside down in shallow water, where the remaining rockets fired uselessly into the sand until they burned out, leaving only smoke and the smell of cordite and the absolute silence that follows near disaster. Bell walked down to examine the wreckage at low tide, his boots squelching in wet sand, and saw immediately that the fundamental design was unworkable. No amount of reinforcement or guidance systems could compensate for the inherent instability of a rocket-propelled wheel. The variables too numerous, the tolerances too tight, the whole concept fundamentally unsound, despite its theoretical elegance on paper. Yet orders from the Admiralty Experimental Works insisted on continued testing, the invasion of France now scheduled for late spring, and there existed desperate institutional momentum behind any weapon that might reduce casualties on the beaches, no matter how improbable its success. So Bell authorized construction of a third prototype, incorporating what lessons could be salvaged from 2 failures, knowing that the next test would likely be the last chance to prove the Panjandrum's viability before the project was shelved or canceled outright. The metal drums and rocket brackets and explosive payload represented not just material resources, but the hopes of men who believed that British ingenuity and unorthodox thinking might produce some miraculous solution to the terrible mathematics of amphibious assault against prepared defenses, even as evidence mounted that this particular miracle was not going to occur, that some problems could not be solved by rolling bombs or rocket-propelled wheels, that the Atlantic Wall would have to be breached through conventional means, through blood and fire and the grinding calculus of men advancing across open sand into machine gun fire, exactly as military planners had feared from the start. 8 March 1944, Westward Ho, Devon, England. The third and final test began at 1400 hours under conditions of absolute secrecy, the beach cleared for half a mile in both directions, the Home Guard maintaining perimeter security while senior officers from Combined Operations Headquarters observed from a concrete bunker normally used for anti-aircraft fire direction, among them representatives from Admiral Lord Louis Mountbatten's staff, who had reviewed the previous test reports with increasing skepticism, but who remained officially committed to evaluating all potential assault technologies regardless of earlier failures. The final Panjandrum prototype incorporated every modification Bell's team could devise. The drums now reinforced with additional steel bands, 120 rockets distributed in 5 separate rings around each wheel to provide redundant thrust, a weighted central axis designed to lower the center of gravity, shock-absorbing mounts for the rocket brackets, and a revised ignition sequence that would light the rockets in waves rather than simultaneously, though these improvements added weight that pushed the total mass to nearly 2 tons, including a full payload of dummy explosives. The device sat at the waterline, looking more menacing than ever, its metal surfaces painted with non-reflective gray. The rockets clustered so densely around each drum that they overlapped, the entire assembly suggesting some artifact from an alternative history where Victorian engineering had continued unchecked into the 20th century, producing machines of Baroque complexity and questionable function. At 14:15 hours, with all observers positioned at safe distance and the cinematographer ready to document what would be either triumph or definitive failure, The electrical firing system closed, and 120 rockets ignited in rolling sequence across both drums, the sound building from thunder to continuous explosion. White smoke pouring across the beach in clouds that obscured the Panjandrum for several seconds until it emerged, traveling at tremendous speed, the wheels spinning so fast they appeared almost solid. The entire device racing up the sand with what seemed like murderous intent, tracking straight for the first 30 yards before the familiar pattern reasserted itself. Uneven thrust, differential burn rates, rockets detaching and spiraling away in corkscrewing trajectories that sent observers diving for cover. The main assembly beginning its inevitable turn as asymmetric forces overwhelmed any stabilizing effect from the increased rotational speed. What happened next entered the folklore of British experimental weapons development as either comedy or tragedy, depending on perspective. The Panjandrum, now completely out of control, veered sharply inland and began racing directly toward the observation bunker where the senior officers stood watching, the device trailing smoke and shenning rockets, closing the distance at 40 miles per hour, causing a scrambled evacuation through the bunker's rear door as flag rank officers and technical observers fled the approaching weapon, some with more dignity than others, while Bell watched from his separate position with the detached horror of an engineer witnessing the complete failure of his design compressed into 30 seconds of rolling chaos. The Panjandrum missing the bunker by perhaps 50 feet before one drum struck a concrete anti-tank obstacle and the entire assembly disintegrated in a spectacular shower of fragments and rockets and smoke, pieces of wooden drum and metal hardware raining across a 100-yard radius. No injuries except to pride and to the project's viability, which died conclusively at that moment despite never being formally canceled. The official report, filed 15 March 1944 with the Directorate of Miscellaneous Weapons Development, stated in careful bureaucratic language that the Panjandrum project was being suspended pending further research into guidance systems and propulsion reliability, but everyone involved understood this meant permanent abandonment. The device's failure complete and absolute, its design flawed at such fundamental level that no amount of modification would produce a battlefield-ready weapon, and within weeks, the remaining prototypes were dismantled for scrap metal, the rockets returned to stores, the blueprints filed in archives where they would remain classified for 30 years, and Bell reassigned to more conventional ordnance work where the laws of physics operated predictably and where explosive devices moved in straight lines or did not move at all. On 6 June 1944, when Operation Overlord commenced and Allied forces stormed the Normandy beaches, the Atlantic Wall was breached through naval gunfire, aerial bombardment, specialized armor vehicles called Hobart's Funnies, and ultimately through the courage of infantry advancing across open sand exactly as planners had anticipated, without benefit of rocket-propelled rolling bombs, and the casualties were grievous, but the invasion succeeded through conventional military competence rather than experimental weapons, proving that some problems require old solutions, that there exists no shortcut past the brutal realities of amphibious assault, and that not every desperate innovation produces results worth the resources invested in its development. The Panjandrum remains a footnote in the history of World War II weapons development, occasionally mentioned in memoirs and technical histories as an example of wartime ingenuity pushed beyond practicality, a device that looked impressive in theory and absurd in practice, a wheel that could not be steered, a bomb that endangered its operators more than the enemy, a weapon that embodied both the creativity and the futility of trying to engineer around the fundamental difficulties of modern warfare. And its legacy exists mainly in declassified film footage showing a massive drum careening across a beach, trailing smoke and chaos. A brief moment when British determination and engineering ambition combined to produce something that was simultaneously magnificent and completely useless. A weapon that went out of control because it was never truly in control, because the premise was flawed from the beginning, because some ideas should remain on paper where they can do no harm, and where they can preserve the dignity of the men who conceived them in good faith during a desperate war, when any idea, no matter how improbable, deserved at least one chance to prove itself on an empty beach in Devon while the tide came in and the gulls cried overhead, and the real invasion prepared itself through conventional means that would require no rolling bombs, No rocket-propelled wheels, only ships and aircraft and men advancing toward defended positions with the tools they understood and trusted, leaving the Panjandrum to rust in military scrapyards and persist in memory as a curiosity from a time when Britain was willing to try anything, even the absurd, even the impossible, even a weapon that seemed designed by committee or madness in the hope that something might work, that some innovation might save lives, that the war might be won through genius rather than grinding attrition, a hope that proved false with the Panjandrum, but which drove the entire war effort and which history judges not by the failures, but by the eventual victory that came despite them, purchased with courage and blood and conventional weapons that moved in predictable directions and exploded where they were meant to explode and required no rockets attached to enormous wheels rolling uncontrolled across the sand.